Hey everybody, thanks for joining. Today we're going to do more Claude Code projects. First I'm going to review what I've been working on. I think the last thing uploaded was the audio noise background app. I since used Claude Code to make a bank brokerage or a brokerage bonus website, which I'll just quickly go over, and then I'm going to start a new project today, and I think that will be fun to stream. Yeah, but just quickly, so I made this website called bonusprofessor.com. It's actually to track bonuses that you get from brokerages, as you might think. At any given moment, there's many different bonuses being offered, and for brokerages, they're actually quite lucrative. I mean, if you have, say, $100,000 of stocks, those are already invested and they're earning some return. You can even be invested in bonds, like the SGOV ticker, which will give you about 4% a year. And then the bonuses from the brokerages will just add on top of that. So for example, if you had $100,000, you could get these bonuses. The catch is you have to subscribe for a year. Anyway, if you are interested, you can actually watch one of these videos. I made some videos using Notebook LM. That's weird. I thought yeah. So yeah, there's these YouTube videos. I just ran Notebook LM over this website.
Oh yeah. Well, right now brokerages are
and yeah, it compares the different bonuses and explains what they're about. But yeah, it's the thing that didn't exist in the bonus community. Was this kind of like graph I wanted. So if I had to transfer a certain amount, what's the best bonus? And it's not just the raw dollar amount you care about. You actually care about how long the brokerages make you hold the stocks in their brokerage to get the bonus. So you can figure out the actual APY. So for example, Robinhood offers 3%, which is really high for a bonus, but you have to hold it for 5 years. So it's less than 1% a year. With the lower APY, you can just, change brokerages and get more bonuses that way. Anyway, this was fun to make. Had a little web scraping, and I don't think I'll be making any money off of this, but it's actually a useful tool for myself, and some people in the community want it. I got some feedback on Reddit. People seem to like it. But anyway, yeah, that's just one project. It took, I'd say, yeah, the prototype was done in a day in Claude over 2 sessions, and then it took a lot of refinements, say another 5 sessions or so to get exactly where I wanted. And then yeah, using again Cloudflare pages to host it for free. It's very nice. Cool. So with that being done, today I want to work on something near and dear to my research interests. So this one is going to be quite a bit more technical than the previous ones. Yeah, this is probably only interesting for myself and a few people in the research community, but we're going to do some deep learning models. At Google I did some speech quality models and some codecs, which try to compress the speech down and to a small amount of information, so as few bits as possible, and tries to recreate it at a high quality as possible. So there are many different areas you can work on in speech, but recreating the speech or the input signal is a fundamental one. So the one I want to actually work on today is this idea of noise. Noise and entropy. So when you have speech, you have tones, right? If I just hold my my speech, like if I hold a vowel, like it's running at a certain frequency. It's a pitch. But when I say other kinds of consonants, the plosives or the fricatives or the sibilants, these are not voice. They don't have a tone. So, for example, if I say shh, there are no real tones in that. They can be colored by a range of frequencies, but it's a very noisy signal. And what I mean by that is tones are often represented by sinusoids and harmonics, which are just more sinusoids at a multiple of the frequency. And then the noisy part, sibilants, which is really, so sinusoids, to refresh your memory from trigonometry, they're like very clean looking up and down waves. And then the noise part is just unpredictable. It's just like dots. If you're looking at the waveform, it's dots everywhere. And this is a part of speech that's interesting. It's actually it's there's information in there. When we say shh, we are actually like trying to transmit some information. It's not noise in the traditional sense where it's something you don't care about. But as far as the signal goes, it looks very noisy. So we still call that noise. So the part I want to work on is that there was a model called SoundStream that was fundamental at Google, and a lot of things were built off of it. There was WaveLM, for example, that used it to make other interesting generative models. And there's also our codec called Lyra. Okay, so great. We have Niska now. That's the speech data set for quality. But anyway, the thing we're going to try to do is recreate something like SoundStream, but use but handle the noisy part of the signal differently. Yeah, in particular, what we want is I'd like the model, so the way we compress things down with SoundStream, for example, is you start with the full information. You pass the waveform in, waveform input, shrink down to a smaller bottleneck at a low rate using convolutions. Decoder uses the convolution or the bottleneck to resynthesize the input. There were a couple losses. There's like a discriminative loss and also an adversarial loss. So I'm not sure to what extent Claude is going to be able to help us with this, but I'm going to try to give it as much as possible. So the main difference here is from sound stream so we want to handle the noise differently, and that means pass. Okay, so the training data is entirely synthetic. Okay. And these are the noise source. We pass the noise sample to the decoder as well. And the idea here is that the what is it exactly? The idea here is that the bottleneck won't save information about the actual phase values of the noise, because this information has been given to free for free in the decoder. The catch is the training data set consists of tones or noise, and the noise is filtered to create the input sample. Okay, but the original noise generator sample is also saved. One additional loss, we want to train on pairs that have the same filters, frequencies, but use different noise sources, noise samples. So these should sound exactly the same, but they will look very different in terms of the actual waveform when it's noisy. When it's a sine tone, it should look exactly the same. But the loss should ensure these features at the bottleneck are as close as possible. Okay. Inference. I want to be able to take a waveform and run it through, optionally also providing a noise source. If not provided, sample it. Okay. I can also give it the code for, not the code because SoundStream was never released. There are some GitHub variants, but what I might do is give it this give it this SoundStream paper. So let me just save SoundStream paper. Okay. Oh yeah, and by the way, the reason I didn't upload the bonus professor stuff is it ends up being kind of hard to deal with API tokens and like private things in a live stream. So it was just a little too messy there, and even stuff showing stuff like my downloads folder. It's a little embarrassing, but it's not crazy, so I'm fine to upload these. Okay, so let's start doing Claude things. So I have this empty Git repo. There's nothing in this directory yet. So let's start up Claude and let's have it do whatever it wants. Hey, please read this paper and help me implement my new project. I'm just gonna paste this stuff in. Wonder if I can just maybe just copy and paste the I guess the latex would have been the best. But I'm just gonna I don't know what the best way to do it is. I wonder. Okay, so what I'll do is maybe it's okay. So I can also tell it the location of the paper. I think would also be useful. Paper at file. Okay, so I have no idea. Oh, I might be out of Claude, which would suck. Well, let's get going. Okay, go. All right. It's gonna read the paper. And let's see how far it gets. It's going to do in Torch, which is fine. And I'm just going to let it go. Maybe I'll look at what it's doing. I should tell it to commit things. Commit things regularly. Okay, it's already doing some things. So let's work on the data set first. Yeah, just add as much as you want, commit as much as you want, please. Yeah, just commit. So let's check this out. It's generating noise. I like it to save the noise in full band, so it's maximum entropy. Let's see. Alright, so there's a couple filters. Later we can do notches and things like that, but right now I just want some tones. It'd be good to have chirps so we don't have like just static tones, which are pretty easy. Let me make a note of that. So let's add chirps, moving tones, envelopes to the tones and noise. Alright, but this is like a reasonable generation for a toy data set. And it's doing this consistency pair thing, which I asked for. That's nice. Yeah, I think it's okay. I just want to check that it's actually saving the noise source. I don't see that. Okay, it does. Alright, so it has the noise source. I'd also like to be able to sample that, so I should say, please let me sample the noise source. Use that to run inference every 100 steps, 100 train steps or so. I also forgot to tell it I have a 3090. I have a 3090 I want to. Yeah. And output the waves, input and inputs, loss, noise source, okay. So cool, it's doing a lot, it's still going. But yeah, I think this is going okay. I'm gonna look at the model next. So let's see, we've been going about 25 minutes now. Okay, it's done with the scripts. I'm gonna look at some of those. So let's look at the full model. Okay, very simple, right? Encoder, decoder. Conv block, let's see, licky ReLU, looking good. The downsample factor is all 4, which is not ideal. Usually we have some different numbers. I think this is going to be too heavy, but we'll see. It's reasonable to start with this, I think. Okay, it says we're ready to start training. Let's try that. Before we do that, I'm gonna give it this feedback. Let's see if it committed everything. Sometimes it doesn't. Oh, it did. Okay. All right. Will this work? So while it does that, let's keep looking. Okay, so there also is training pipeline. Yeah, it looks like it's set up for CUDA. So this is all pretty good. This is much better than the last time I used ChatGPT. Let's see how it handles the losses. And let's see how it uses the noise source. So we want to make sure the noise source is passed into the bottleneck as well, right? So self.model handles this. All right. So let's look at the model, full model, I guess, because this is the one that connects the encoder and decoder. All right, so the init just creates the thing, but the forward is the one that deals with the noise source. Yeah, so it is doing that. Great. The noise source goes to the decoder. The other thing I want to do is look at our consistency loss is also. Yeah, let's see where the losses are actually used. Okay, so there's a generator loss. Okay, so we have to look at our losses, which are probably in another file. Yeah. So, oh, there's a spectral loss as well. All right. Yeah, our feature matching loss. I don't understand why there's a real and a fake here. Yeah, so this consistency loss is the one we do want. So the defer entropy loss probably combines two of these losses. Yeah. And this is a class, right? So generator loss adds a lot of these together. Probably add the losses up. And the total loss is the weight of these. How are the weights set? Okay, the weights are set with some value. That's fine. All right, let's try this. That'd be cool if it just worked, but I don't expect anything. I don't even know if it's going to write the model checkpoints out, but looks like we need lib sound file. I should just tell it to train, so it can deal with this. How about you train till the first checkpoint, eval, and show me the files, sensor board. Okay, so it's gonna do it. Let's just try that. Yeah, go ahead. All right. So yeah, it's going into some CUDA errors. Yeah, just go ahead and do all that. I believe, I just want to make sure we have our driver set up. I think so. I mean, strange that it's doing these like array type things for the CUDA problem. Because these errors are not about the metadata. I feel like it just doesn't know what CUDA is. Am I wrong? Maybe the error is about an array? It could be. Yeah, I remember there being some weird CUDA problems. Let me see. Oh no, so that error was okay maybe. We should tell it to fix that error. But it was not a fatal error. Alright. The training is working, huh? A more basic thing would have been try to replicate the results for paper in the future. So if this doesn't work, I'll go and do something like that using toy models. But from the code so far, I think this will work. Alright, so now it says things are working. Let's see, does it just like kill the model? Oh yeah, but there's a tensor board now, so that's great. Alright, so let's do this. Okay, so we'll do that. We'll be training. Let's also. Oh, great. So. Tensor board. Log deer logs. Okay. Oh, we don't have tensor board installed. Maybe it would give me a nice way to install it. I don't want to installing TensorFlow, the whole thing kind of sucks. Hope there's just like the package I install if I'm using PyTorch. Okay, it's a pip install. That's nice. No, you don't have to run that. I'll run it. That didn't work. Okay, you run TensorBoard. I got Singer. Int source. But let's see how this is going. I can also check, see how much my GPU is being used. I don't think this is a lot, but it's something. 32. Yeah, but I don't see the. Doesn't look like we're actually training on the GPU. I could be wrong. I mean, that usage is a little high, but it might just be all the browser windows I have open. Would like more feedback on this training. I mean, that's what TensorBoard would be nice for. All right, so it says TensorBoard's running. Let's try that. Okay, so it is running. Usually the x-axis is steps, but can't tell if that is the case here. Also don't know why there's 4, 7, 8 models. Oh, maybe that was one of the parameters, num workers. Oh no, I guess, okay, so it's doing distributed training locally. That is interesting. But yeah, it's doing it probably on CPU, which is way too slow. Oh right, so it took about, I don't know how long, but it took a long time, maybe 5 minutes or so, to write out the first checkpoint at step 0, which is way too slow. Maybe we can change the numbers, batch size, whatever. Yeah, because I don't think this is running on anything we care about. Alright, let's stop it. It took 5 mins, 4 mins to write out checkpoint 0. Seems too slow. It doesn't appear on NVIDIA SMI. I think it's running on CPU. You also get CUDA errors when you train. No, actually I don't know if you get, let's give it this. Let's just give it my CUDA error. Also want to see an early checkpoint for debug at 5 steps. Okay, so there's no CUDA installed here, which is strange because I remember installing it before, but maybe a recent system upgrade messed things up. But we'll see. We're at 45 minutes. I think this is reasonable progress. But yeah, this is usually the pain point when you're dealing with these system installation, library, DLL hell kind of stuff. That's also one of the things. It's I haven't used this computer that much for development, other than these like Claude projects. Once you have a system set up, things tend to run a little smoother. So this could just be a one-time cost. We'll see. For example, like running Flutter or like Cloudflare stuff now is very easy because the last two projects. Claude does tend to suck with these like versioning problems because it's super hard to figure out from like Stack Overflow or something too. There's usually conflicting information in different versions and stuff. And oftentimes it does like something that's out of date or worked at a particular point in time. But I guess we'll see. I mean, let me look a little bit closer at the actual model. I think the losses probably are good. I haven't looked at the critic. Or the discriminator, but discriminator is a lot easier. It just takes the output and ends with some logits. And if the logits are unsure, you're doing great, right? And I think, yeah, we do a spectral discriminator at different scales, as well as a waveform discriminator. Yeah, but the output should be, I guess it's one-dimensional. Which I can't actually see if this is doing that or not, but I think so. Okay. All right, so I'm gonna use conda to install. Yeah, you can do that. I'm gonna stop the stream in 10 minutes, so ideally we get past this hurdle and we actually hear a sample of something, but I'm gonna guess that we're not going to get that far. We don't know how fast training is yet. We can reduce the model size, batch size, whatever, if we need to. But yeah, that's one of the problems, figuring out what fits on the GPU. And training by CPU is a possibility too, but it's not, and it's actually useful for this prototyping phase, so I might just do that. Because yeah, it's still struggling. I think it might have terminated the install after 2 minutes. Which is not good. Shouldn't do that. So I have to hit Control BB to have it not terminate, maybe, which is weird. Okay, so it says things are working. Let's see. I don't understand. It said things are working, but it says still downloading. Alright, it's a big download. Oh, so it decided to start training for me. Okay, so I can ask it for the background tasks. Oh, it says it finished it already? That's surprising. Why is the screen flickering like this? I don't know, but yeah, with batch size 4 and non-worker 0, it's much faster. Let's see. still not running anything there, but it says it's still installing. Let's see how that's going. Okay, so it says it's done now. Great, it's installed. So what do we got? We got 5 more minutes. Let's see where we get. CUDA available false. So that's not good. No, this doesn't tell you if it's running on GPU or not. And it's still not, so that's not great. Yeah, so I'm running OBS to capture the desktop and make this recording. That's probably what's using the GPU. All right, so it wants to try a new shell. Could just, maybe it could source things. Okay, but I don't know, mixed results, I'd say. Still can't see how local training is going. Let me add a mode where the loss shown for every step, evaluation steps, evaluation is shown. These aren't appearing in TD. So for next time, I definitely want the GPU stuff to get working. I might look into that on my own. But yeah, for 1 hour of this, I wasn't able to hear even early step audio, which is a little disappointing. But you know, on the plus side, it created all the models, and the training pipeline seemed kind of reasonable. We didn't ask it to do crazy things, no real data augmentations. We still haven't passed the actual speech files in or have a pipeline for that, which will only be done in inference for this model. I expect that will not sound super good, but if you can kind of capture some of the noise, I think that'd be nice. All right. Yeah, I didn't actually check to see if it added the chirp. Oh yeah, so it kind of did. So Let's see how it does. Yeah, so it has a moving tone somewhere. Yeah, and it uses linear modulation. For the frequency. Yeah, that actually sounds okay. And we just adjust the phase. Great. The kind of envelope is, it's funny, I've never seen hand and hamming alongside attack, sustain, decay, release. But yeah, the first two aren't the kind of windows I was thinking about. Envelopes. So yeah, I'll give Claude a 4 out of 10 for this kind of work. If I'm just talking about like prototyping, I'll probably give it a 6 to 7 out of 10 because I think this is pretty useful still. For writing that boilerplate code and implementing the paper logic. I'll still have to go back and check all of that. I mean, the actual like convolutions were quite different, but they seemed like not insane choices. So yeah, I think I will just stop the stream here, but thanks for being my rubber duck, and I appreciate it. And see you next time.